All right. Good afternoon, everybody. Class recording has started. It'll be a short class recording, seeing as how class is over in about 8 minutes, but that's cool. So, all right. So, big part of Unit 5 deals with circuits and different parts of circuits, different things that go along with those circuits. So, it says here, in order to measure the voltage current, VI characteristics, right? V for voltage, I for current, of a lamp, a student sets up the following electrical circuit. So first, part of your data booklet is a list of, okay, closed it whenever you want to close it. So.
Is that a light?
Say again?
Is that a light?
That is a variable resistor, not a light dependent resistor, but a variable resistor. I'll show you. One of the things I was going to show you is that your data booklet has all the symbols. So, and here they are.
What does that mean? Variable?
Means that it changes, that you can change it. Just like a variable in math class is something that
How
changes.
does it help problem?
Well, the biggest thing here, and we'll get into this a little bit more, is that well, here, let's look here first, right? So here's all your symbols, right? This is a battery, right? Okay, so we have a battery in that circuit. A switch is just obviously just like an open break here. V stands for voltmeter, for obviously measuring potential difference. A stands for ammeter, which is for measuring current, okay? A resistor is just this rectangle, but a variable resistor is a resistor that we can change the resistance on. Biggest example of this would be like a dimmer switch on like a light, where you can change what the brightness of the light is. By changing the resistance at the switch, you either allow more or less current to flow through the light, and that causes it to be brighter or not as bright. So that's like simple one.
And with the battery?
Yep.
The cell or whatever?
Yeah.
Which way does it go? I know there's the traditional one, but it's like a false one.
Usually big side is the positive terminal, little side is the negative terminal. So electrons are going to flow out of here and into here, but conventional current goes the other way. Yeah, so. Well,
I know because of the...
yeah, it's basically like when we were discovering these electrical concepts, we didn't know about protons and electrons, and so the idea of current was based on the flow of positive charge, but we didn't know at the time that negative charges are really the ones that move, and so it's kind of like all of these, like the right-hand rule and all that kind of stuff, are set up off of a positive charge flow, even though that's not really what happens. So, I don't know, it kind of sounds to me like people are just lazy, like, oh, we've always done it this way, let's just keep it, but it's not. So, and then two big things, right, here's our lamp, right, and then there's some other things on there, but we're not going to get into a lot of that stuff. So, all right. So here we have a battery, we have a lamp, and then we have a variable resistor. So first, it says, add circuit symbols showing the correct position of an ideal ammeter and an ideal voltmeter that would allow the voltage current characteristics of this lamp to be measured. So potential difference, right, voltage, needs to be measured in parallel, because you need to measure the voltage or the energy at one point and another point. So if we're measuring allow the VI characteristics of the lamp to be measured, we are going to have to put the voltmeter in parallel with the lamp, all right? So we can measure the difference in energy between here and here. Voltage always has to be measured in parallel, okay? Current needs to be measured in series. So we could put the ammeter basically anywhere, but we could put it right here because that's just before it flows into the light bulb. It doesn't necessarily do anything to the lamp, but it does affect the current flowing through the lamp. Well, because what kind of a circuit is this? This is a series circuit. What's true about the current in all parts of the series circuit?
So when you go to the end.
Right. So in this case, if we increase the resistance here, that slows the current in all parts of the circuit. Right, and then the intensity goes down because not as many charges are flowing through, et cetera, et cetera, et cetera. So, yeah, that's what the variable resistor is for, is to increase or decrease the overall resistance of the circuit, which affects the current flow and blah, 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 blah. Okay. All right, good there? Explain why the potential difference across the lamp cannot be increased to 12, cannot be reduced to 0. All right, so here's the deal. All right, internal resistance of the battery. Okay, this battery has internal resistance. So first, are we good with the idea of what resistance does? Resistance converts electrical potential energy into other forms of energy. Is that good for a brief description? Okay. So, the battery increases the electrical potential energy of charges, then releases those charges into the circuit, right? If this is a 12-volt battery, ideally, if we measured the potential difference across the lamp, ideally, it would be 12 volts because the charges would gain 12 volts of energy going through the battery, then turn that 12 volts of energy into light here. But some of that energy is dissipated by moving the charges through the battery, the internal resistance of the cell. Also, are these wires completely resistance-free? They're not resistance-free either, right? So you can go internal resistance of the cell, or you can go resistance of the wires. Okay? But because this is 2 points, right, what happens because of this? These things, the internal resistance, requires what to overcome them? To make the current move through a wire that has resistance, you have to push it. Does that make sense? So these things require some power dissipation and those charges get that power, or they get the energy, from the cell, from the battery. So some of the energy that the charges gain going through the battery is used up just to make it move through, so we can't turn all of it into light at that point. Okay. It's the last week, so Monday and Tuesday of the last week. Well, you are going to be taking other exams, you know, like. So. But we do have a little bit of time.